Quadratic functions. This video will help you graph quadratic functions in vertex form and graph quadratic functions in standard form. Let's go ahead here and take a look at a quadratic function in vertex form. So here we have a quadratic function that's written in vertex form, and so let's notice a couple things about vertex form here. First of all, we're going to have a value out front. Could be positive or negative. This is our variable x, of course f of x. We can have plus or minus a value inside here, and then that quantity gets squared, and then we either have plus or minus a value here on the end. So a couple questions for you here, and I want you to think about these things and have you try to answer these things before we start right away here. And it is, okay, so this is going to be a parabola. It is a quadratic, so we're going to have a parabolic graph. You know, this guy's either going to be opening upward or opening downward. And so why don't you go ahead and take a look at our equation here and try to see what you might think would make this thing open up or down. Go ahead and take a stab at this, and then we'll talk about it. But again, it's always best to kind of give it a shot first. Well, if you thought that A was the thing that was going to make it open up or down, you were correct. So it opens up if A is positive, and it opens down if A is negative. And that's kind of handy, because once you have a quadratic function written in vertex form, all you would have to do is look at our front coefficient here to find out whether this parabola is going to open up or down. This might be harder to see, but I'll just give this to you here. The vertex, now remember the vertex of the parabola is either there or there, depending on our parabola. And the vertex is at the point HK on our graph. And so you notice that H is the opposite of the value that's here, and K is the exact value of the value that's there. So our vertex of our parabola is at the point HK. So now if our parabola is, let's take a look at this first positive one here. If that's our vertex, my next question for you here is, the parabola is symmetric with respect to the line. Well, if we know this is our vertex, you know, our line of symmetry is going to go just like that. So see if you can go ahead now and take a second to answer that question. The parabola is symmetric with respect to the line. Alright, well, we know whether this parabola is opening up or down. This is going to have to be an x equals line, because it is a perfectly vertical line. So we know it's going to have to be an x equals line. Well, x is equal to what? Well, x is going to be equal, this line is going to go right through the vertex. So all it's going to be is the x coordinate of our vertex. And notice if we look over here at the x coordinate of our vertex, that's just h. So once we have something written in vertex form, we can know quite a few things about it. We can just look at the graph and we can know whether it's going to open up or down. We can know the vertex point, and we can also know quickly the line of symmetry. Alright, let's go ahead now and use that information we just took a look at there and sketch a graph of this quadratic function in vertex form. So I think to do this, what you're going to want to do is you're going to want to first find the vertex. You're going to want to decide whether it's going to open up or down. And then I think we're going to need to get some points. So the third thing to do here is, let's make a little t-table and just pick some values. Once you find the vertex, you're going to want to pick values on the, on the left and the right side of the vertex and kind of see. So you can just kind of get a general sketch of the parabola. So go ahead, pause your video player now and sketch this parabola out. And when you're done, hit play to see how you did. Alright, let's take a look. So we want to start with the vertex, which is just going to be a point. So let's go to our equation here and figure this out. So x, which is going to be the opposite of that value in there. So my x coordinate is going to be positive 3. This will be my y coordinate, and y is going to be exactly as it is, so that'll be positive 5. Alright, so there's my vertex. over 3 up 5. So let's see, 1, 2, 3, 1, 2, 3, 4, 5. So there's my vertex. Let's see, is this guy going to open up or down? Let's look at A, my value up front. Well, my value up front is negative, so I know this parabola is opening downward. So I know it's coming down this way. Sketch some points. Let's get some points because we need to kind of see how wide this thing opens up here. If it's a wide parabola or it's a narrow one. Before we do that, though, I think the line of symmetry is going to help us. So I'm going to put the line of symmetry. We know here's our vertex. So we know that vertex, sorry, that line of symmetry has to be on the line x equals 3. All right, here's my vertex. Now, one nice thing about this identifying this line of symmetry is if I find a point here, let's say, then I know I get the corresponding point over here for free. So I'm just going to kind of look at some of these values, and then that will give me kind of these values over here for free. So let's see. If I am coming to the left of this vertex, that looks like maybe let's try 1 in there, and then let's maybe try a 2 in there and see what we get. So first thing I'm going to do is I'm going to evaluate this function at 1. Well, let's see. I notice now that I forgot the squared on there. Yeah, hopefully you caught that at the beginning and you put the squared on there, because without that squared, it's not going to be a parabola or a quadratic. So my apologies. We need that square on there. Hopefully you caught that. Plus 5. Let's see. So in here we're going to get 1 minus 3, which would be negative 2. Negative 2 squared is going to be positive 4. Positive 4 times negative 2 would give me negative 8 plus 5. So that's going to be negative 3. So I've got the point 1, negative 3. So let's see. 1, negative 3. 1, 2, 3. So right there. So this guy is going to be pretty narrow. Now, like I was saying before, since we've got our line of symmetry here, if I've got a point 2 over from the line of symmetry at this location, I'm going to get one here as well. And honestly, that's probably enough now to sketch a graph of this parabola. We probably don't need to use this 2 value there. I think this pretty much gives us an idea about this parabola. All right, so let's take another look at a quadratic function written in vertex form. You'll notice again I forgot my exponent on there, but we put it in this time to begin with, so hopefully you'll see that and catch that this time. So same idea. Let's find whether this thing is going to open up or down. Let's find the line of symmetry on there. We did that last time. That was helpful. And let's find the vertex. I'm not sure what this little mark is here, but this is just a plus. This is not a plus or minus sign. That's just a positive sign there. This is some sort of little glitch here in Word. So ignore that kind of negative sign above. That's just x plus 3 quantity squared. All right, go ahead and pause your video player and graph this thing. All right, let's take a look. So we're going to need the vertex. And let's see. So my x-coordinate will be the opposite of what's listed there. Since it's plus 3, my x-coordinate will be minus 3. My y-coordinate will be exactly as it's listed, so negative 1. So I've got my vertex at negative 3, 1, 2, 3, negative 1. Now, whether this thing opens up or down, my line of symmetry is going to be right there. So I can put that in. And let's see, that is the line x equals negative 3. And it's here. So now that I have my vertex and my line of symmetry, I want to check and see if this guy's going to open up or down. Well, we see it's positive in front, so we know this parabola is going up. Now we just need to determine how wide or how narrow this parabola is. So let's pick a point on the left of this, and then we'll get the symmetric one over here on the right. So let's see, I'm at negative 3 right now. I'll try negative 4 in there. So I'm going to evaluate this guy at negative 4. So we're going to try f of negative 4. And so I'll have x. And so I'll have negative 4 plus 3 quantity squared minus 1. All right, let's see. Negative 4 plus 3, well, that's negative 1. Negative 1 squared is positive 1. So 1 minus 1 is going to give me 0. So at -4, I get 0. So if I was over here at -4 getting the point 0, since this is my line of symmetry, I'm also going to get that one. Now, that's not quite enough to see what's happening here, so let's kind of jump over maybe 2 units from the vertex. So let's try 1, 2. That would be -5, I believe. 1, 2, 3, 4, 5. Yep, -5. So let's try to evaluate f of -5. So let's see, -5 plus 3, quantity squared minus 1. -5 plus 3 is -2. -2 squared is +4. 4 minus 1 will give us 3. So at the point -5, which was right here, we are up +3. 1, 2, 3. Well, we'll also get this other point over here, symmetric one. Now that's pretty good. Now we can get a good sketch of this parabola here. Not trying to be perfect, just get a general sketch of these things. All right, we've taken a look at the vertex form. Now let's take a look at another form of a quadratic function, and that is the standard form. And the standard form is something you've probably already seen before in mathematics. You know, here's my f of x value. F of x is ax squared plus bx plus c. Well, I'm going to show you some things here that will make this easier to graph. But before we do that, let's see if you can answer this question. The parabola opens up if, and then down if. Take a second here to see if you can come up with those reasons for when it's going to open up or down. All right, well, if you guessed A, you're correct. Basically what happens is this coefficient, since it's getting multiplied by x squared, will dominate or overpower any of the other terms in here. So this one is really going to determine how the parabola behaves. So it opens up if A is positive, and opens down if A is negative. So hopefully you saw that. All right, the vertex, which is not quite as easy to see, but if we take these values here, -b over 2a, and these values are just coming right out of my quadratic function. So if I take -b divided by 2a, I will get the x-coordinate of my vertex. To find the y-coordinate of my vertex, all I have to do is take that value and plug it back into the function. Remember, if I plug this x value in here, it will spit out the corresponding f of x or y value there for the other coordinate of my vertex. Okay? So let's see if you can answer this one now. So we've got this point here, -b over 2a as my x-coordinate. Here's my y-coordinate when I'm graphing these things. My question here for you is, the parabola is symmetric with respect to the line blank. So go ahead and give that a shot and see if you can come up with that line. Well, hopefully you came up with this. We've seen this before. They're all going to be x is equal to something. In fact, they're going to be equal to x is equal to the x-coordinate of my vertex. Remember, if I have my parabola here, opening up or down won't matter, and I've got my vertex here, the line of symmetry is going right through that vertex line. And so, since this is an x equals line, it's just going to be the x coordinate of my vertex. And if we look back here, we know that is the x-coordinate of my vertex. So it's going to be x equals -b over 2a would be the coordinates of my symmetry line. All right. The other thing we're going to use here is nice to use when we're sketching graphs is the fact that the x-intercepts occur when my f of x value is equal to 0. Right? If I had a graph here and I had, let's say, my parabola and it's crossing there. Right? These x-intercepts are going to occur when my f of x value is equal to 0. And so to find the x-intercepts, all we need to do is we need to just substitute 0 back into my function here. Substitute 0 in there and then solve this quadratic equation, set equal to 0, which we've done a lot of times before in other classes. All right, let's go ahead now and use that information. And we're going to sketch a graph of that quadratic function. I also want you to use the x-intercepts like we talked about, and also let's use the vertex, which we just talked about, -b over 2a. So go ahead and pause your video player now. sketch a graph of this quadratic function, and when you're done sketching it, then go ahead and let's identify the domain and the range of the function. Alright, well, just like when we started with vertex form, I think it's going to be to our advantage to identify the vertex. And notice what I'm doing right here. This is a great way to start memorizing math formulas and terms. Is just start by writing out the formula or term before you use it. And you'll have to look a couple times when you're starting this out. But after a couple times of this, you get used to writing it. It'll become second nature, and you'll memorize it. And when you get to the end of the unit and you're trying to memorize all these formulas, you kind of almost have them memorized. So good idea there, good tip is to just write down these formulas before you start using them. Okay, so now that I've got it written down, let's go ahead and figure out what these values are. Let's start with our x-coordinate here. So negative b, which is 4, positive 4, so negative 4 over 2a. Well, a is negative 1, so that's just going to be negative 2. So it looks like I'm going to get a value of positive 2 there for my x-coordinate on this vertex. So now to find my y-coordinate, all I'm going to do is plug 2 back into my function. So let's evaluate f of 2, which would be negative 2 squared plus 4 times 2 plus 1. Let's see. I'm squaring this first and then taking the opposite of it. So this will be 4, negative 4, plus 8 plus 1. So let's see. Negative 4 plus positive 8 would give me positive 4 plus 1 would give me 5. So I know the vertex of this quadratic function is at the point 2, 5. So let's get that down. 1, 2, 1, 2, 3, 4, 5. So there's my vertex. Let's go ahead now. We know our line of symmetry has got to pass through that. So I'll go ahead and sketch that out. All right, let's see, up or down. So if we look here at A, well, it's negative, so this is definitely going to open down. Let's sketch a couple points around this vertex here and see what's going on. Okay, so I've got my vertex 2, 5. Now what I want to do is I just want to kind of get a hold of a couple points on either side. And we talked about finding the x-intercepts here. So that's going to happen when my f of x or y value is 0. And I think we're going to get 2 x-intercepts here because notice this parabola is opening downward. It's going to cross in 2 locations. So let's go back up here to my function, and I'm putting a 0 in for f of x, and I'm going to solve this quadratic equation. So let's see, 0 is equal to negative x squared plus 4x plus 1. All right, so first way to try this always is factoring. So I'd have a negative x and a positive x. Ooh, this guy's not going to work because I got a 1 on the end and I'm supposed to get a 4 to the middle. I can tell already this guy's not going to factor. So that's going to take us now to the quadratic formula. Okay, so once I have my quadratic formula written down, it looks like I've got a is equal to negative 1, b is equal to 4, and c is equal to 1. Getting those values from right up here. Okay, so let's see. I've got negative 4 plus or minus the square root of 4 squared minus 4 times 1, times negative 1 times 1 all over 2a. Well, a is negative 1, so that's going to be all over negative 2. So let's see, negative 4 plus or minus the square root of 16. Looks like this is going to be in positive 4. So let's erase that. That's going to be 20 inside of there. All divided by negative 2. All right, and so what we're going to want to do here is we're going to want to use our calculator to just kind of get a close approximation for these guys. So I'm going to take the square root of 20. Okay, so I get out my calculator and I plug that in, and it looks like I'm getting positive 4.2 and negative 0.2. So let's come up here and try to estimate that. So 1, 2, 3, 4.2. We'll just say that's about there. and then the other one is negative 0.2, which would be about there. Now let's make sure we've got symmetry here. If we didn't, oh, I don't have my point there. Let's make sure we got symmetry here. So let's take a peek. If we go from our line of symmetry, it looks like I go over 2 plus 0.2, over 2 plus 0.2 more. So we've got symmetry. We've got a nice way to sketch now our parabola. And let's try to get that a little curved up there. Okay, so now once I get my graph sketched, now I'm ready to identify the domain and the range. Let's come over here a little bit. So remember, domain is my input values. If I look here at my values of x that I'm inputting into this function, there are no restrictions. There's no values that I could plug in here for x where I end up with something is undefined. There's no holes or breaks in my graph, so my domain is going from negative infinity off to positive infinity. And remember, I use parentheses around there because negative infinity and positive infinity are more of an idea, so we can't exactly pinpoint those values down. So we don't ever want to put a bracket on those. And let's see the range. So it looks like my lowest value here, diving all the way down, is negative infinity. And then we can climb all the way up to and including this vertex point, which was again at the point 1, 2, 3, 4, 5. So we're going to include 5 here, so we would put a bracket around that. And again, negative infinity is an idea, so we just put a parentheses around that one. All right, let's take a look at this next question here. Without graphing, identify the maximum or minimum of the quadratic function. And then identify the domain and range of the function. My goodness, and I'm having all kinds of trouble here with my typos here. 4x squared was what we needed for that one. So let's all recognize that's 4x squared minus 16x plus 100. Now it will be a quadratic. Okay, so we want to, without graphing, identify whether it's going to be a maximum or minimum. And I think this has to do with, if you just think about the shape of a parabola, either going like this or going like that. I think you could think about how you could figure that out. And then once you figure out this max or min, then let's identify also the domain or the range of the function. All right, go ahead and pause your video player, and if you got to sketch something a little bit, that you can do that to get an idea, but it would be nice if you could just do this right without graphing. All right, well, as I kind of hinted at before, if we have a parabola that's opening up, then we know that we're going to get a minimum value down here. If we have a parabola that's opening down, we know the vertex is going to be a maximum value. Well, let's see what kind of parabola we have here. This was positive 4x squared, so it's opening up. So this is going to be a minimum value at the vertex. So let's go ahead now and find the x and y coordinates of this. So again, let's write that down. Negative b over 2a, and then we'll take the function and plug that point in there to figure out my f of x value. So let's see, negative b over 2a. So negative b, so b was negative 16, so it's going to be positive 16. A was positive 4, so 2 times 4 would give us 8 there. So it looks like that's going to be an x coordinate of 2. Okay, so now I want to evaluate the function over here at 2. So let's see, 4 times 2 squared minus 16 times 2 plus 100. Good thing we're not graphing this because this is going to be a large number here. Let's see. 2 squared is 4. 4 times 4 is 16. 16 times 2 is 32 plus 100. So this is going to be, if I add those together, that'd be negative 16 plus 100. Let's see, that'd be 84. So we're going to get this coordinate 84. So there's my vertex. So I know this is my vertex, the point over 2 up 84, and we also know this parabola is opening up. So this 84 is a minimum value. So it's a minimum value so not at. No, we could say a minimum value at 2, 84. And we would say the domain Well, there's, again, no restrictions on the domain here. 4x squared plus minus 16x plus 100. There's no spots where it's undefined. So our domain is negative infinity to positive infinity. And our range, well, the lowest value it's going to start at, we said this was a minimum value of 84. And it's going to take off to infinity. And I can make a mistake here, so let's do this. We're including 84. So we want to put a bracket